condition, greater than condition, less than condition. So if the content of the two registers under comparison instruction will be performed, then the zero flag will be set if the content are equal. If the content of the accumulator is greater than the second operand stored in the any one of the register, then carry flag will be reset to 0, and the zero flag will be 0. And the third condition, that means when the content of the accumulator is less than the second operand, then the carry flag will be set. So carry flag will be set for the third condition, and the zero flag will be set on the first condition. So the result is reflected in the status flag in case of a compare instruction. So this is a compare instruction. The format is comp R. R may be one of the instruction. Registers like comp B, comp C, as well as the compare may be the content of the memory locations, comp N. That means three conditions will be set. Conditions of the comparison will be reflected in the flag registers. That means if the content of the accumulator is less than the registers of the memory location, carry flag will be set. If the content is equal, zero flag will be set. If the content is greater, carry and zero flag are reset. I see. Sorry. That means in case of a logical operations like comparison operations, so the three conditions will arrive: equality, greater than, and the less than. So when the two operands are required under the instruction, for example, comp B, one of the operand in the accumulator and the second operand is the B register. If this is a condition which will occur, the carry flag and the zero flag will be set accordingly. So second operand in the second example is the memory location content, and the first operand always in the accumulator in case of 8085 instruction. And the condition of the flag will be set or reset according to the result of the comparison operation. So that is the meaning. It is compare immediate. The second operand is explicitly defined in the instruction itself, not stored in the register. So that's why the CPI, compare immediate. The first operand is always in the accumulator, always, in case of 8085. So these are the example of the AND operation. First operand must be in the accumulator. The second operand would be explicitly defined in the instruction. So this is AND immediate. So in this manner, the comparison operation can be used, or instruction. This is ORing, or immediate, and this is or between the accumulator content and the registers content or memory locations content. This is exclusive OR. So like that. What will happen in case of exclusive ORing? That means when the bitwise, the two operand, one in accumulator, another in the register, will be same. So bitwise operation for exclusive under exclusive operation. So when the content of the two input value of the bit, what will happen for exclusive OR operations? That means 0 0 means 0, 1 1 means 1. That means when the two bits are different, then only the exclusive OR will produce a high logic level. So that means if the content of the one content in accumulator and the content in B register are different, then and then also what will happen? The outcome, the result of operation will be 1. Now, why the result of operation? The content of the accumulator are ORed with the content of the register memory location. The result is placed in the accumulator. The result means what is the operations bitwise? So bitwise operation means that means when the two bits at the respective bit positions are unequal, that is 0 or 1, then it will be set to bit. So that's why the result after exclusive OR operation will be 1 by number, binary number. That should be clearly understood. But carry and the auxiliary carry flag will be as usual reset. And also the 0 flag will be reset. So that is the purpose of exclusive OR operation. For example, exclusive OR immediate with the content of the accumulator with the explicit operand, immediate operand H6. So if the content of the accumulator is different from the H6, then under bitwise operation, what will happen? The respective bit becomes 1 if it is unequal. But if the content of the accumulator is H6, then what will happen? The bitwise content is same. So the result of operation will be 0. So the accumulator will store the 0 result. And if the accumulator content is 0, then the 0 flag will be set, parity flag will be set, sign flag will be set in the flag register. But the carry and the auxiliary carry, AC, will be reset. So try to follow the logical operation and the consequence in the flag registers. Rotate already I have explained, rotate right via carry, rotate right without carry, rotate left as well as the rotate left via carry. Now, what is the branching instruction? Branching instruction means the mnemonic is jump and the 16-bit operand is required, that is 2034. That means during execution of this type of branching instruction, the CPU will branch and starts fetching the instruction from this location 2034, which is in the valid memory location. So this is called the unconditional branching. Whatever may be the condition stored in the status flag, the branching will occur at this 16-bit address location in the second operand of branching instruction. But this is conditional branching. That means jump if 0 flag is set, JZ. So if 0 flag is set, it will check, CPU will check the 0 flag, then the CPU will branch to this location. So this is called the conditional branching. So these are the 4 branching, 1, 2, 3, 4, 5, 6, 7, 8, 8 branching operation if the conditions are set. But if it is no C, that means no carry, that means carry flag is reset. So JNC stands for jump if no carry. JC stands for jump if carry. Similarly, JZ, JNZ. JM, that means for a sign bit addition or sign bit operation, JM, if the jump, if the minus. Now you have to understand the sign bit arithmetic, binary arithmetic. I will explain during programming part. So these are the conditional branching, and this is unconditional branching. That is the operation of the branching. There are other types of the branching operation called. In fact, it can be done in a different way. Either a single program and another second method is programming with the help of subprogramming, subroutine. So I will explain what will happen in case of a subroutine programming. So in case of a subroutine programming, this is one kind of the nature of the branching. Name of the mnemonic is call. That means by this type of instruction execution, the CPU will branch automatically to 2034 locations where the program code for subroutine are stored from starting from this location. And at the end of that subroutine residing from this memory location, the ending instruction will be returned, RET. That I will explain. So CPU will automatically come back to the part of the program where the calling has been done. That means just next instruction automatically. Otherwise, if we write jump 3024, CPU will only jump, but it will not return until and unless it will encounter the return instruction. So there is a difference between the jump and the call. Call is used in the subroutine programming purpose. So these are written. There is a operation code or opcode NOP. Nothing will be done. It is an idle opcode. Only it will consume some time, T states, by the execution of the instruction NOP. HLT is another kind of instruction. After execution, the CPU will go to the halt state. What is halt state? This must be understood. During halt state, CPU, all the buses, address data buses go into the high impedance state, neither low nor high, and CPU will start fetching the opcode. So it will be permanently at halt state until and unless the power is withdrawn. So if the power is in the next time, CPU will start fetching the instruction upon power and reset condition from 000 location. That is the first locations of the address space. So that is the implicit. That means in fact the halt instruction is used at the end of the program, HLT. So CPU will come out from the halt state when an interrupt or the reset is necessary to exit from the halt state. That is it. So DI and EI are the different types of the instruction which are used for the interrupt process. This should be learned afterward. What is interrupt process? What are the different types of interrupt? Now, where you will apply this programming code. That's why you have to learn the before that, the instruction can also be classified according to the nature of addressing mode. What is meant by the addressing mode of the instruction? To perform any operation, we have to give the corresponding instruction to the microprocessor. So according to the nature of operation which has been described, we can. In each instruction, the programming has to specify three things. The destination of the result. Why? What is that? The method by which the address of the source data or the address of the destination of result is given is called the addressing mode. The term addressing mode refers to the way in which the operands of the instruction is specified. There are 5 addressing modes for instruction operation: direct addressing mode, register addressing mode, register indirect addressing mode, immediate addressing mode, and implicit addressing mode. What is the meaning of this? Direct addressing mode. Say we have used the data transfer instruction LDA. So this is the instruction LDA followed by the operand. What is the operand? In memory locations in an absolute way, 2500 hex. So load the content of the memory location 2500 to the accumulator. That is the meaning of the instruction. It is a data transfer instruction. Direct. This type of addressing mode is called the direct addressing mode. That means in this mode, the address of the operand 2500 is given in the instruction itself. What is the address of the operand? The operand is nothing but a memory address 2500. So LDA is the operation, 2500 hex is the address of the source. Source means from where the data will be moved to the accumulator. That is why it is source. So accumulator is the destination. That means the source is nothing but a memory location whose address must be explicitly specified with the instruction itself, and that is why it is called the direct addressing mode. And the data will move from the source, that is the memory location, to the accumulator, a single byte register. So that is called the destination. So that's why in the definition, the method at the classification addressing mode, the method by which the addresses of the source of data or the address of the destination of the result is given is called the addressing mode. What is the mode? Direct addressing mode. This instruction belongs to the category of the direct addressing mode. Why direct? Because the source address is directly explicitly defined in the instruction itself. Then What is the register addressing mode? The next instruction, move A comma B, is an example of the register addressing mode. In this mode, the operand is in general purpose registers. So there are two operands, accumulator and the B registers. Where is the source registers? B register. Where is the destination register? Accumulator. So that's why both of the operands are stored in the two different registers. So that's why the name arises register addressing mode for this instruction, move A comma B. This is also the data transfer instruction. So this is the interpretation of the addressing mode of the CPU instruction. Register indirect addressing mode. This type of instruction, the source is the memory locations M as pointed or addressed by HL pair registers. That is the name implies that will move A comma M. So data will be transferred from the memory locations to the accumulator. And the destination is a register, A registers. So that's why what will be the type of the addressing mode? Register indirect addressing mode. Why indirect? Because the source location is indirectly pointed by the HL pair, another register pair. So that is why the naming, the source is addressed by the indirect way. That is why it is called the register indirect addressing mode. Example is that. Then immediate addressing mode. It is also a data transfer instruction where the operand related to the source data is explicitly defined in the instruction itself. It is neither stored in the registers or stored in the memory location. That's why 05X. That will be moved to the accumulator, the destination register. So that's why the name implies immediate addressing mode. That means the source data is addressed immediately in the instruction itself. Example is this. Implicit addressing mode. In fact, 8085 has only few instructions which are this type of addressing mode. One of the which is called the complement the content of the accumulator, CMA. The address of the source of the data as well as the address of the destination of result is fixed. It cannot be altered because it is fixed by the manufacturer. So that's why there is no need to give any operand along with the instruction. Neither extra operand is required in the instruction. It is a single byte instruction. It has no operand. So instruction itself has its inbuilt operand. That is the content of the accumulator will be complemented. So it is called implicit addressing mode. That means addressing of the source and the destination register both are in the accumulator are implicitly mentioned in the instruction itself. So these are the example of the 5 different kinds of addressing mode. So try to understand that means how to classify the instruction according to the mode of addressing. We have become familiar about the nature of the operation as well with the instruction. That is different. But how in a particular, whenever we are using the instruction, how the addressing is done, that will be defined by the addressing mode. Why this is required, knowledge of this addressing mode is required? First of all, by defining or fixing the addressing mode, the real-time program, it will help the user to develop the real-time program. That means how the program can be executed with a shortest possible time of time states. So real-time programming requires that knowledge. And we'll whenever we'll write the programming in assembly language, then why the addressing mode will be useful, it is required. Otherwise, for writing the program, you require the knowledge of different types of instruction based on nature of operations. So the addressing mode, the concept of the addressing mode is required very much. Then required Then any program is a combination of set of instruction following the mnemonic and the operand. So this is called the assembly language program. Why assembly language? Because in computer language or CPU language, there are different hierarchies, high level, low level, etc. So assembly language is the intermediate level. It is neither high or nor low. It follows a particular syntax following a keyword and the grammar of the language or the syntax of the language. But low level language is called the machine language. So that is only understood by the CPU itself. User or programmer cannot understand. Program can understand assembly language because it has a definite syntax, a definite keyword or grammar. So any program should be developed in by using the assembly language, which can be further converted to the machine language by compiler or assembler. That means some kind of a translator. So that's why a microprocessor executes, that's why these are the salient points. A microprocessor executes instruction given by the user. The instruction should be in the language known to the microprocessor. That is the step, that is the machine language. So microprocessor understands the language only 0 and 1, which is a part of the machine language. The language is called the machine language. So microprocessor can understand the machine language. It cannot understand anything high level language. These are the example of the machine language. A particular byte binary number says an instruction, copy the value of 2h in the register A. The meaning is like that. So we have noted that there are 246 types of the instruction in case of 8085. And 246 types of variants are possible for a 8-bit binary number. And these are the examples. For example, this binary number indicates a machine language grammar, which is add the content of the two operands A and B, and the result will be stored in the operand A. So now comes to the assembly language. According to the instruction classification, we have learned what is the meaning of the different mnemonic under different nature of operations. The mnemonics are moves, add, sub, these are the example of the mnemonic. Or instruction. So this is called the mnemonic. But the instruction cannot do anything until and unless it has got the operand part. For example, these are the examples. MBI A, the mnemonic part followed comma 2H. 2H is the operand in hexadecimal number, which indicate the copy the value to hexadecimal 2 in the register A. So these are the mnemonic. These are the instruction which has got opcode part or mnemonic part followed by the operand. So these are called strictly the assembly language because this is understood by the programmer or the user, but cannot be understood by the CPU. CPU can only understand the stream of binary language, and this will be decoded by the instruction decoder in its internal architecture. So that's why there is a flow diagram. Writing the program in assembly language by the programmer or user, it must be converted to the machine language with the help of a software assembler. So this is nothing but an assembler program. A program known as assembler is used to convert the assembly language program to the machine language. So this can be understood by the CPU 8085. So low level, high level language or the meaning has got a specific meaning. There are different high level language in computer technology, basic Pascal, C++, C, Java, etc. So for each of these high level language, the different compilers are required. And this is the programming model of the 8085, because this is a programming model which resembles to the internal architecture. So now comes to the overview of the 8085 programming model. Example of the data transfer program. So these are the instruction or assembly instruction. And these are the meaning of this instruction according to the nature of operation. For example, this instruction means load a 16-bit number 2050 in register pair HL. Read the input port whose address is 07 hex, and the result will be stored to the accumulator. So we copy between the input and the output port, that means for out instruction, and for in instruction reading operation will be done, and for out instruction writing operation will be done from input accumulator to this port. And for these are the example of the arithmetic instruction. These are the example of the logical bit manipulation operations. These are the example of the branching, using the branching instruction. And these are the example of the machine control, HLT, NOP, etc. As well as DI, EI are the machine control. Disable interrupt, enable interrupt, we'll discuss more about those. So steps to write a program: analyze the problem, develop a programming logic with the help of flowchart, write an algorithm or flowchart. These are the two parts under the development process. Write and program instruction using assembly language of the 8085. Examples are these: add two numbers, store the result in C. So this is the algorithm part. Some programs require, some operation is complex and the algorithm is required. Otherwise, algorithm may not be required. To develop the algorithm, flowchart may be required. So this is the nature of the flowchart for a related problem given to you. This is the assembly language program along with the comment. So this is the last step. How the program will be executed according to the steps in the algorithm, this is illustrated. So these are illustrated with this, all these things, giving the example. Addressing modes of the instruction used in a given problem are also discussed. Already we have just discussed what is the interpretation of the addressing mode.